Okay, so we'll start in a moment. And before we have Grafana, which will take center stage and are much more interesting and talented than I ever will be, I invite you, of course, all to join. We have beers throughout. We'll have to come, join, sit. We're starting. Yes, it's actually happening. We have Grafana that will, as I say, join us momentarily. It's almost 5:30, and as promised, we'll start at 5:30. I just wanted to give a few words. So welcome everyone to Taboola. We're the content recommendation platform. We provide over 3 billion web pages a day, and we do this on multiple websites that you probably have visited or seen. Everyone's still shell-shocked that I'm actually speaking. Like, why is he talking? He's not Grafana. We don't want him. So it's, I promise, just one minute longer. We provide over... guys in IT, you need to stop connecting to the Zoom meeting and talking. We provide over, as I said, 3 billion web pages a day, and that brings us to about 30 billion recommendations. Most of you surfing in Israel see us on websites such as Ynet or Walla or other places, and globally we are located on sites such as MSN and ESPN and many, many others. So serving the kind of global web with recommendations, providing each and every recommendation personalized for each and every user. Anyone wants to kind of guess numbers of unique users a month? Just to see that you're actually listening and interacting with me? 600 million. Thank you. Someone actually answered. So it's 1.5 billion users, unique users. So those are kind of the numbers. And to observe all what we do and to monitor all of the different services that we provide, we of course use the amazing products out of Grafana. So with no further ado, I'll pass us on to the Grafana people.
Thank you, Ariel. Okay, so just to give you an idea of the agenda, we're going to get started now with Tom, who's our VP of Product, who's going to give us a talk about Cortex and Thanos. Then we're going to have a talk from Taboola, who are going to give an idea of their journey with metrics and with Grafana. Then we'll have a quick break, and you can grab another drink and grab a bite to eat. And then we'll come back with Dita from Grafana Labs, who's going to give a talk on MetricTank and Graphite, and also the roadmap for Grafana and the exciting things that are coming in version 7. Okay, so I'll pass over to Tom, and we'll get started.
Cool. Thank you, Ed. Can everyone hear me okay? Excellent. I don't speak Hebrew, I'm afraid, so I'm going to do the talk in English, and I'm going to try and talk very clearly and very slowly, but if anyone doesn't get what I'm saying, just stick your hand up, and I'll repeat myself. I'm afraid we're trying to figure out how to cover up the window back there because there's a beautiful sunset outside and we're just seeing the reflection. So today I'm going to give a comparison between Cortex and Thanos. These are two projects. It stopped working. Excellent. That's a good start, isn't it? I'll stand over here then. These are two projects. The whole thing stopped working. What is going on? Yeah, it's sorry about this, guys. It's my laptop, it's not. All right, let's try again. This never happens, I promise. Yeah, there we go. Right, so Thanos and Cortex, these are two projects designed to make Prometheus, a very popular monitoring system, designed to make it more scalable, more highly available, and more, have long-term storage. So the two projects, I gave this talk at PromCon in November in Munich. So this is a repeat, I'm afraid. I gave the talk with Bartek, the author of Thanos, and he did the Thanos bits and I did the Cortex bits, but unfortunately Bartek couldn't be here, so I'm going to try and represent Thanos. I'm actually the chap who started Cortex 3 and a bit years ago. So obviously I'm a little bit biased, but I'll do my best to fight those biases. Yeah, Cortex and Thanos, they're both CNCF projects. The CNCF is the Cloud Native Compute Foundation. It's the same foundation that looks after Kubernetes and Prometheus and 20 or so other projects in the cloud native space. They're started around the same time, about a year apart. You know, they're both very mature projects. I think suffice to say, Thanos probably has more users than Cortex. But I would say that Cortex probably has slightly a hand over it on scale. So we're going to focus this talk around 3 different properties that both systems have. They're both set out to do the same thing. What they do is do it in very different ways. So the first thing is a global view. In the Prometheus land, you try and align a Prometheus server to a location. Prometheus needs to be able to scrape metrics from the jobs it's monitoring. And so it has to really be in the same region or the same data center as those jobs. And if, like Taboola, like Grafana Labs, like many companies out there, if you run in multiple locations, you need multiple Prometheus servers. And this leads you down the path of, well, how do I run a query over the data that's in multiple Prometheus servers? So that's the first problem that Thanos and Cortex try and solve. Second problem is high availability. What happens when one of my Prometheus servers fails? We, again, try and solve this in very different ways. The standard Prometheus mantra here is just run 2 of them. If you can't get a response from one, get a response from the other. But as you'll see, there's various shortcomings to that approach. Then the final thing, long-term storage. Prometheus itself has a pretty good, decent storage engine. You can actually store data almost indefinitely on a Prometheus server, but that's confined to a single server. You know, if that server fails, if that hard disk fails, what do you do? So Thanos and Cortex are both trying to give you solutions for like really durable long-term storage. So global view. In the Thanos world, the situation is relatively straightforward. You deploy what's called the Thanos sidecar on every single Prometheus server, and then you deploy a central set of Thanos queryers. You then point your Grafana or any other leading dashboard solution at Thanos, and Thanos will fan out the queries, fetch all the data it needs to execute the query from the Leaf Prometheus servers, bring it all in centrally, and then process the query there. This works very well, super easy to set up. The challenge, as you'll probably see, if you have to, you know, it's very easy to do a query from Grafana that might cause Thanos to fetch gigabytes, maybe even terabytes of data from all of the Leafs. And these Prometheus servers could be the other side of the world, right? So they've got to ship all this data over the internet. So sometimes this can cause, you know, a lot of data to be brought into one location. You know, it could be relatively easy to cause Thanos to run out of memory. It could, you know, generally be a bit of a challenge. The other problem here, the way Thanos works, and I'll cover this a bit more in a minute, the way Thanos works is Prometheus is building these blocks, these compressed files on disk with the last 2 hours worth of data, and then Thanos takes them and puts them in an object store. So what this means is when you do a query to Thanos, if the network connection to one of your Prometheus data centers, one of your data centers with a Prometheus server in, is down, then you don't get the data for the last 2 hours. These are the problems with Thanos. The positive side is this is super easy to deploy, really straightforward and simple, and it's really lightweight. Right? There's not a lot of stuff to do to make this work. So let's look at Cortex. Cortex does it the opposite way around. Cortex has each of your Prometheus servers push data to a central location, to the central Cortex cluster. Cortex itself is horizontally scalable, so the more servers the more Prometheus, the more metrics you have, the bigger Cortex cluster you need. And Cortex then stores this data in some kind of NoSQL database. We'll cover that in a minute. Queries are all therefore executed in a single location. Now, as you can see, as long as you can connect to the Cortex cluster, you can query the data in that cluster. If a connection between the Prometheus and the Cortex fails, Prometheus will buffer up the data. Buffer up the data that's not available. But up until the point that the connection has failed, that data has made it into Cortex and can be queried. So normally those kind of metrics will give you a good sign as to why that, you know, what was going wrong in the minutes or seconds before that connection went down. So these are the 2 big differences. You know, realistically, Thanos is a kind of fan-out federated query system, and whereas Cortex is really a push-based centralized querying system. Yeah, let me just check my notes, see if I've missed anything obvious. I don't want to do, I haven't got my notes because of the screw up. So yeah, so that's really the first difference. How do we execute a global view of the queries? In Thanos, we fan out. In Cortex, we push into a central location. So let's look at the second one, multi-replica Prometheus. As I mentioned, the best practices in Prometheus land is to deploy 2 Prometheus servers and have them both monitor the same set of jobs. What happens here is not just if one of these servers fails, but if you have to stop one and upgrade it. There'll be a few minutes where that server has to replay its write-ahead log, where you have to upload the new binaries. And this will result in gaps in your graph. And I've tried to do a very crude drawing here of gaps in the graphs. So if you just go and query a single Prometheus server, you'll see a gap. You go and query the other one, you might see a different gap. So what we really want is a system that can kind of merge the two results and give you an answer that doesn't have gaps. So Thanos does this, again, at query time. The central Thanos querier will do the fan out, fetch all the data, and then centrally it will deduplicate that data and give you a graph with no gaps. Pretty cool. You see the graph with no gaps in Grafana. If you do this with Cortex, what happens is both pairs in the same data center push data to the central Cortex cluster. And then as the data is being written by Cortex, it gets deduplicated. So we will decide which of the replicas is the authoritative one, and we will therefore only store one copy. And then, yeah, you can see that's a bit of a small picture there, but you can see the one copy just in the storage and the one copy in Grafana. At the end of the day, these two systems achieve exactly the same result, and they have subtly different trade-offs. If you look at the Thanos way of doing things, this is again, easy to deploy, less moving parts. It leverages your existing Prometheus storage. If you look at the Cortex way of doing things, you're storing only one copy instead of two. There's less data, there's less work to do on queries. This will give you slightly better query performance. The other thing to consider in the Thanos world is when one of those servers does go down and you only have one replica, Thanos will show you gaps from that single replica. In Cortex land, because these pushes have happened when the data's been scraped, as soon as the data's been scraped, even if one of the Leaf Prometheus servers goes down, you will not see gaps in your data. Sometimes you can see in a Thanos system, if servers are coming and going, then you'll get subtly different results depending on when you ask the question. Cortex only ever records a single copy of the data, so we'll only ever give you the same result. That being said, just to give one negative of Cortex, we have to make a fully consistent decision when we ingest the data in Cortex as to which replica we're going to choose. So we use a relatively simple timeout. If we haven't seen a replica for a minute, we'll choose the other replica. We store that information in etcd or console, one of these two systems. And so this means there's an extra dependency. There's another thing you have to deploy to get this feature in Cortex. And you have to operate an etcd cluster, you have to monitor that. So yeah, that's really, you're probably starting to get a handle on the trade-offs here. Cortex has tried to do things in a way that's very scalable, very performant, but generally a bit more complicated to deploy, a bit more moving parts. So, final one, long-term storage. This is where they actually differ the most. The previous two ways, mostly it's just the direction of the RPCs. Long-term storage, completely different. In Thanos, as I touched on before, blocks are built locally by the Prometheus, and these blocks tend to be about 2 hours long. And then every 2 hours, the Thanos sidecar will take a block and we'll upload it to S3, to GCS, to whatever object store. You could use MinIO, you could use Ceph. Thanos then has another component called the Thanos store that can accept the same interface that the sidecar accepts, the store interface, and can do queries and answer queries based on what's stored in S3 or GCS. The queriers in the middle of Thanos, that will merge the results from these two sources and give you a single source, a single result. I must say, this is the big strength of Thanos. Object storage is incredibly cheap. In Cortex land, we use, Bigtable, Cassandra, DynamoDB. These systems are more heavyweight, they're more expensive. This is the big benefit of Thanos. So in Cortex land, as I said, Cortex is this horizontally scalable time series database. We actually rely on either a Cassandra or a Google Bigtable or an Amazon DynamoDB to do the storage for us. The richer interface that this gives us, we can, not only can we just get values by keys, but we can do range queries, we can build a proper index, and we can, fetch smaller amounts of data. This allows us to have pretty good query performance, especially when compared to Thanos. But I won't lie, there's more moving parts and there's more bits to maintain and configure. One of the things we've done in Cortex is we put a lot of effort into caching as well. So you'll find, if you've ever seen running Cortex cluster, there are caches absolutely everywhere. We use Memcache for a lot of things. We're starting to use Redis as well. Yeah. So, two big differences. Thanos uses these TSDB blocks in an object store. This is very, very cost effective, but it's a bit harder to query. You know, there's no index, so the index gets stored in a block, and the index has to be loaded on startup, and blocks have to be listed on startup. So there's a few challenges, but generally super cheap. Cortex, on the other hand, uses a NoSQL database, a bit more expensive, but a lot richer, allows us to have much better startup times and much better query performance. So do you think I've been fair so far? Do you think I've been unbiased? Some of you are looking a bit skeptical. So this talk was given 3 months ago, so the future is now. We've been working with the Thanos team. Bartek lives in London. Him and I go for brunch every Wednesday, and we kind of plan world domination together. We've been working to try and take a lot of the techniques we've done in Cortex to accelerate queries and apply them to Thanos. So we've taken, there's this component in Cortex called the query front end. I'm terrible at naming things, so it's the thing that sits in front of the queryers. You can also put this in front of Thanos. And what this will do for you is this will cache query results, so that if you ask the same query twice, it can give you an instant response. This will also take queries and break them up into smaller queries, allowing Thanos or Cortex to parallelize those queries and answer them quicker. And it will do, you know, there's a whole host of tricks in there that it will do to try and accelerate your queries. Heavily inspired by a component called Trickster from Comcast, but just written in a slightly different style. If you put this in front of Thanos, you start getting a lot more similar query performance to that you see from Cortex. And then the other way around is also true. We're big fans of Thanos' storage model. We think it's great, it's easy to operate, it's cheap. And so we've been taking the code, not taking, like vendoring, contributing to, you know, collaborating on the code in Thanos and starting to use it in Cortex. So that you can actually run Cortex in a way that only depends on S3 or GCS. This exists, this works now. Query performance isn't quite there yet. We're still seeing this being about twice the latency of a Cassandra or DynamoDB-based system. But we're working heavily with the Thanos authors. Marco in my team is doing all this work. I can't really take any credit for it. But we're doing a lot of work to try and accelerate Thanos queries so that it gets the same kind of performance as Cortex. And as you can see, when you have both of these systems combined, you kind of get the best of both worlds. So there we go. That's my talk. What do you think? Any questions?
Yeah. If the data is stored in can I use it in MetricTank, like data studio or whatever? But I can, in my view, long-term storage is like a different question. I think
So the question, I'm just going to repeat it for the recording. The question was, the data stored in BigQuery, can I use it for analytics as well? The data stored in Bigtable, not in BigQuery. These are two different services. Yeah, Google's naming scheme is super confusing. But you can do, one of the things you can do with Cortex and with Thanos is you can do long-term analytical queries over your data using PromQL. So we use Cortex and Thanos to do like capacity planning. You know, what's the trend been over the last 3 months, 6 months, so on. We use it to look at diurnal patterns, to look at growth, to look at like sizing, all this kind of stuff. But I would encourage you to do it in PromQL. PromQL is better than SQL anyway. So at the back. So the question was, does Cortex support remote read? It does. We actually, Julius and I first, when we started the Cortex project, the first things we did was build the remote read and the remote write interface in Prometheus. And since then, we've built a new remote write interface, which supports the write-head log for buffering and is much more efficient. And actually, Bartek, one of his big contributions to Prometheus, has been a new remote read interface, which now supports streaming. Thanos relies really heavily on remote read to access the last 2 hours of data in Prometheus. So he's built a really optimal version of that that massively reduces memory and CPU. But yeah, Thanos uses it. Sorry, Cortex does.
is there a minimum for data?
So if you use Cortex as a long-term solution or Thanos? Okay, if you use them as long-term solutions, is there a minimum amount of data? There's, on Thanos, you need to keep a couple of hours, right? You need to build these blocks locally on the Prometheus and then have the sidecar ship them off. After that, you don't really need to keep them. I mean, I think the config we use keeps the last day, but it's somewhat arbitrary. On Cortex, there's no requirement. Data is shipped. Data is read from the write-ahead log in Prometheus and shipped out as quickly as we can. And in fact, we're working on a version of Prometheus, a really lightweight agent that doesn't even store anything locally. So an agent that just does service discovery, scrapes your jobs, and then sends data directly to Cortex. Thank you. Question here. Yep.
So what about Cortex? How does it?
So the question, I'm just going to repeat it for the recording. The question is, Thanos supports downsampling, and what about Cortex? So the chunk storage that I referred to here doesn't support downsampling. The Thanos storage in Cortex obviously does support downsampling. So you can kind of have the best of both worlds. But downsampling is a really interesting topic because most people come to me and say, I really want downsampling. And when I dig into why do you want downsampling? Downsampling is a solution. What's the problem you're trying to solve? Most people think it will make things cheaper, think it means storing less data, but it doesn't, right? In the Prometheus world, when you downsample a single series, you tend to output, I don't actually know the exact answer, but like 10, let's say, extra series. So you actually tend to write about the same amount of data as you've read in, maybe slightly less or slightly more, but it's not the order of magnitude reduction that you'd think. So what downsampling is really useful for in Thanos is accelerating queries, because it means you don't have to read as much data when you do like a one-year query. And this is not actually a problem we have in Cortex, because we've taken a very different approach, right? We've tried to parallelize and shard our aggregations as much as possible. So we can do a one-year query against raw data in seconds. And in Thanos will take the same or slightly longer, but it will look at downsampled data. So we don't support downsampling, but I don't think it's necessarily a massive problem. Does that answer your question? Thank you. How long have we got? Oh, I'm ahead of time. Okay, one more question. Go on, someone. Ed, that's a plant. So Ed's on the commercial side, I'm on the engineering side, but Ed is asking me how Grafana Labs makes money and why we're involved with Cortex. So we run a service called Grafana Cloud, which offers hosted Prometheus, and the technology behind the scenes that we run that on is Cortex. We also support a couple of pretty large clients with like support contracts who run Cortex on premise for themselves. So yeah, if you want to talk about any of that, then we've got commercial people in the corner. Awesome. Okay. Anyone else, or should we wrap it up there? Nope. Good. Thank you very much.
Okay, so we're going to hand over to Taboola, to Michael, who's going to talk about metrics and Grafana at Taboola.
Can you hear me? Yeah, cool. Okay, let's get started. So, hi, we'll be talking about monitoring at scale, and my name is Michael. So, let's begin. So, our agenda for this talk will be basically monitoring and metering as a concept. We will talk about Taboola, specifically history of metrics, how we did it from the beginning up until today. And we'll talk about our current solution, which is based around Prometheus. So just some words about me. My name is Michael. I'm married, I have a daughter, 4 cats, a dog. I've been with Taboola for a year now, and I'm part of the infrastructure engineering group here. So, for those of you who do not know, what's Taboola? Taboola is the leading content recommendation company in the world. What we do is we recommend to readers what they should read next. This can be native content from that page or different pages from that publisher, or this can be sponsored content. The idea is to keep the readers interested in providing them more content without them going looking for it. Some measures of data, just so you understand what we deal with on a day-to-day basis. So we have around 105 even today, billion unique users a month. We have about 3 billion page views daily, 500,000 requests per second, and we have about 80 terabytes of incoming data per day. From all the different systems across our ecosystem, we generate today something around 100 million unique metrics. So, monitoring is a very big concept for us. As part of our development is very oriented towards metrics. Basically, each and every part of code that's being added to the system comes with its own metrics. The developers, it's part of our culture to add a metric to anything we do, so that we'll be able to monitor it, understand if there's issues, and add automatic alerts so we'll be notified once something happens in the system doesn't correlate to what we expect. We split metrics into 3 basic types. You have the application level metrics, something that's coming from the business logic of our code. We have machine metrics, CPU, memory, and such, and custom metrics. It's metrics that we create for systems that don't expose metrics by themselves. So let's go into the history of metrics for us. So in the beginning, we had one developer. His name was Adam, no metrics, and the world was great. Everything worked from the first line. As we grew, from the perspective of the number of developers and the number of metrics, we needed to get some sort of infrastructure to support it. In the beginning, for us, it was something called Mooning. It's an open source created in 2003, based in Perl, and works around RRD tool. Basically, what it does is the metrics are stored locally on each server, and the web server for this basically connects, creates, based on the data points, a PNG and stores them in the server. So when I access a metric, I actually get a picture back. And it works for a time. There's even an example of how those graphs looks. Grafana looks better. But as with everything in the system, we keep growing. We add more machines, more developers, and sadly, it just doesn't scale. The main issues for us were the pool intervals were too long. We had no really flexible dashboards. You had a set of dashboards that you could use, and you can't really create your own. There are no aggregations based on a number of servers. You can look at one server, you can't aggregate a group of them. And there are scaling issues around Perl and RRD tool, which we couldn't really go above. So the next stop on our journey was Graphite. It's also an open source, it's scalable, it's widely used. It has a very rich query language with functions. It uses Whisper as its time series database. General architecture of Graphite surrounds around 3 parts. You have the Graphite Web, which actually allows you to create dashboards, and you can query them from there. You have the Carbon, which actually is responsible for ingestion of metrics, and you have Whisper, which is the database for that, which stores the data in the form of files. Specifically for us in Taboola, this is how we handled the shipping of the metrics. At this stage, we already have a number of data centers. And for us, what we did is, in each server, we have a Graphite reporter. It's responsible for pushing out the application level metrics. These metrics are pushed into RabbitMQ. We are also using Sensu to create custom metrics and system metrics, and to collect them, and again, ship them to RabbitMQ. From each data center, we ship the metrics using replication to a RabbitMQ, which is located in Israel. Once they're here, we use Carbon Relay to ingest them and to store them. From the moment we ingest them, these metrics are available through the Graphite web. Even at this stage already, the tools that we're using to create dashboards and display were not really working for us, and we adopted the first version of Grafana in 2014. It's pretty much the first versions that came out. But again, as with everything with us, it doesn't last. So what happened now? Graphite was good for a time, but it has inherent issues. As the amount of metrics we generate grew, RabbitMQ was no longer capable of maintaining the transport for us. It wasn't capable of passing that much information. In addition, the way that the database in Graphite works, it has consistent hashing, meaning that when I add a server, I need to manually move the files representing the metrics from server to server to satisfy the hashing. So this creates a really big hassle when you want to scale your cluster. In addition, the transport to move the metrics from one data center into another data center is complex. This creates a very complex solution to operate, maintain, and monitor. Here comes MetricTank. So, MetricTank is also an open source. It's been out from 2015. It's fully Graphite query compatible, supports matrix downsampling, easily scalable, and stores its data in Cassandra. One of the points that we chose is that it didn't require us to make any changes to our dashboard. It's the same query language, the same metrics, so we don't basically need to change anything. It's a very easy transition for us. This is a diagram from the MetricTank GitHub. So just as a general explanation, MetricTank comes as a single server. It can ingest from Carbon, Kafka, HTTP. It stores its information in Cassandra. And it uses the Graphite web to expose the metrics for Grafana to retrieve them. Specifically in our case, the transportation of metrics from all the data centers, because at this stage we have even more data centers, was done as the following. We created in each server a new reporter, this time a MetricTank reporter. It was responsible for collecting the metrics from the service and pushing them, this time, into Kafka. The Sensu was still responsible for reporting the system level metrics and the custom metrics. It was doing it in the same manner through RabbitMQ, and the Carbon Relay was pushing them into Kafka. One small note, for us, in order to optimize the replication between the Kafka in each data center and the Kafka NAL, we were batching the messages into a batch and sending that batch into Kafka. When MetricTank was pulling the information, there was a separate topic that was responsible for retrieving the batches, opening them into single messages, and that's what MetricTank was actually reading for us. It helped us to scale and to support the transport in the meantime. And again, issues, always issues. So the amount of metrics keeps growing and growing and growing, and again, MetricTank is no longer capable of sustaining us. As before, we have a lot of moving parts, even in the system, mostly in the transport layer. It's very complex to bring metrics from all the data centers into IL. We have a lot of configurations. We need to maintain Kafka topics. We have services that read from one topic, create batches, and store them. The MetricTank itself is a very big cluster with a lot of resource intensive. One more thing that we encounter is we have a daily downtime. We saw that when MetricTank flashes the data to Cassandra, it reaches 100% CPU and doesn't really answer any queries. The result of this for us is that daily we have about 10 minutes when we are blind. We don't actually see any metrics. It's a very problematic case for us as we are very dependent on what happens in our system. Also, we saw that MetricTank is having a hard time handling legs. If a leg reaches a certain point, MetricTank can't really handle it. It will simply crash. And we reached its capacity. It was hard to scale higher. So we reached today. We needed to find another solution and see how we progress forward. In our case, the solution was Prometheus. So Prometheus is an open source from 2012. It's a proud member of the CNCF Foundation. It has no moving parts. It's a single package that does it all. One server can scrape over 100 million metrics. It changes the paradigm because up until now we were pushing metrics into the servers. Prometheus goes and pulls that information. Prometheus namespaces are a lot more flexible. They add different dimensions. If in Graphite you have only, let's say, the metric name represented, here you have the metric name, and you have different labels that you can add. So you can query not only based by name, but by different labels. The language allows you to aggregate labels and create different labels or add labels from one metric to another. It's a lot more flexible. One more selling point is the alert manager. Up until now, when we wanted to alert about something, we had to write our own code that queried the metric and send an alert. Here it comes built in. The Prometheus itself can run an alert rule and use the alert manager to trigger a notification to PagerDuty, Slack, or any other manner. One additional selling point is we are very heavy users of console, and Prometheus supports service discovery. So when we want to add a service to the scraping and collect the metrics, it's very easily done through the console. Basically, Prometheus has a set of rules for each service of what port you need to scrape from. And when we add a service and register it to console, it will automatically start collecting metrics from it. So it's very easy for us. Specifically in cases where you have a lot of servers and you can't really technically go and write each and every one of them. So, just to go over the Prometheus architecture. So as I said, Prometheus is a single binary. This single binary provides us an endpoint for retrieving queries. It provides the TSDB that's responsible for storing the data itself and the logic to scrape all the different servers. In addition to that, the Prometheus ecosystem supports the capability of adding exporters to services that do not expose Prometheus endpoints. So meaning if something doesn't really export Prometheus metrics, I can add an exporter. It will collect that information from that service and expose it in a way that Prometheus can easily scrape. In addition, Prometheus also supports a push gateway. It's a very easy way to collect metrics that are not consistent, meaning that I have a cron job that reports the metrics once in 2 days. It will simply use the push gateway to collect it. It won't hassle the Prometheus server itself, and it won't need to add a specific scraping rule that will only be used once in a while. And of course, Prometheus is a valid data source for Grafana. It can be easily configured to retrieve that information. But Prometheus, with all its wonders and good things, still lacks a couple of things. First of all, Prometheus does not provide you any help with high availability. It does not provide you any way to collect information from a number of Prometheus services. This is something that's simply not handled. That is why, for us, we needed an addition. For us, we chose Thanos at the time. So what Thanos does for us is it provides the high availability over the Prometheus. It allows us to aggregate all of the different data centers we have under a single data source and query all the information in one query. It supports PromQL, and it supports downsampling as well. So how do we deploy and use Prometheus and Thanos today in Taboola? So what we do is the following. We deploy 2 sets of Prometheus servers. These sets basically scrape the same services twice. This allows us, in case that one server fails, needs to be taken down for maintenance, upgraded, or anything like that, the other server will still collect the data. Thanos, from its side, reads from both servers. And when it retrieves the information, it dedupes the results, meaning that from the perspective of the dashboard in Grafana, nobody will see that the server didn't scrape or any information was missing. In addition, because we use console to discover our scraping endpoints, Prometheus basically has a very straightforward and relatively small set of jobs for scraping. Basically, each server we plug into the system and is registered to console, we will start scraping it automatically. Today, the way that we retrieve the application level metrics is done through a Prometheus reporter, which is part of our service code. And system level metrics and custom metrics we're collecting using the node exporter. Part of each deployment we do is we deploy the service and we deploy the node exporter with it. This way we are able to retrieve CPU, memory, and any custom metrics that are needed from that machine specifically. But again, this only shows the data center level. We still needed to solve the problem of how we aggregate across multiple data centers. The solution, again, Thanos. So what we did was we created a specific deployment we call cross data center. Basically, we have in IL a Thanos that looks at the Thanoses in each and every one of our data centers. When we execute a query in Grafana using this data source, we basically go across all the world to each and every one of our data centers and retrieve the metrics based on that query. Now, it works, but it's really slow because of latency and because of the amount of data that needs to be aggregated. To solve this issue, we added another Thanos component called ruler. What ruler does is you can create an aggregation rule that will run periodically. For example, for us, it's once a minute. It will execute the query across all the different data centers and store and cache the aggregation. Now, from the moment it creates this aggregation, it's accessible from the data source, meaning that if I query it, it's located close to Grafana, the data is fresh and accurate and exposed at a very quickly for the user. Another specific use case that we found was useful for us was we needed to create one more dimension to our metrics. We have the notion of publishers in our system. Now, usually when we collect metrics, we collect, for example, how many HTTP requests we have per server, how many of them is it now. We wanted to know how many HTTP requests came from a specific publisher that we work with. The problem with this is that because of another dimension, we multiply the metrics. Now, if at first I had only one metric for the number of HTTP requests, now I have multiplied by the number of publishers that I have. It's a lot of new metrics that we can't really store them in the Prometheus. It will simply kill us to even try to aggregate it, to even hold that all. In order to support this unique use case, what we do is we created a set of additional Prometheus servers that what we do is they collect all the publisher metrics for us. And on top of that, they run aggregations. They automatically create aggregations, max, mean, average, on top of all those metrics. These aggregations specifically, and only them, we pull them into the Prometheus and store them for the full retention. The regular Prometheus stores them for about a week, and that's all, because that's pretty much all we can handle without killing our disks. This way we can add another dimension, but adding a dimension comes at a cost. For example, publisher metrics, we have to throw away the definition of server because we need to still limit the amount of metrics that we have. This way we can have another dimension, but at some cost for us. The current challenges. Now, things work. We are capable of scraping, we are capable of adding more services and such, but we did find a couple of things that are still not working for our satisfaction. First of all, we still don't have a valid solution for long-term storage. At the moment, we are storing metrics for about half a year, and we do want to store for a longer periods of time, but we're already reaching the limits of our disks, and because Prometheus doesn't provide you with any way to store that, we're still looking for a solution. We considered using Thanos' downsampling, but it's only cloud-based and it's less successful for us. Thanos is a great solution, but query time is still longer. You're adding one more component, and this component needs to go across each and every data center. And this is additional time that we are spending on this. And one more thing that we saw is because of the amount of metrics that we are using, specifically in Grafana, the Prometheus autocomplete dies. Basically what happens is in servers that expose a lot of metrics, Grafana tries to autocomplete all the information, and the JSON that's returned to it is about 100 megabytes, and the browser simply isn't able to handle that. So for the moment, it creates some less than enthusiastic responses from the development team because they need to wait for the dashboard to load while all of this is being processed. It still works, but they don't really get all the benefits that we're used to from while they work in the MetricTank. It's a pain point. It's not a showstopper, but it's a pain point for them, and we will see how we will be able to address this in the future. Any questions? Yes. Unique metrics. Unique metrics. Each time we reach. I showed only the graph showed only the normal storage. Yeah, total. It's unique metrics for a minute. You're correct. I apologize. Yes, it's on our to-do list. We started looking at it. At the time, Thanos was providing an easier solution for our integration. It was a lot easier to integrate into our system and seamlessly. Cortex is a lot more complex solution. It's on our to-do list because, as I said, we didn't find a long-term solution, and for now, we're still suffering from the query time of Thanos. So most likely, Cortex will be our next step. Yeah. Okay. Specifically in our case, in Taboola, we're on-prem. So all of our data centers are physical. So we don't really want to upload all of our metrics into the cloud. Both for the perspective of how much it will cost us, we have a lot of them, and sending them all the time into the cloud and then retrieving them back is less cost efficient for us. Now, we do know that there is a solution that's called Minion that allows you to deploy something that's similar to an object store similar to S3 locally, but we did not test it yet, and it still doesn't solve for us the issue of the query time. It won't solve that. So it's not the best solution. It will provide some solution, but it's not the best one. Yeah. I'll show you later, but we think about it. We have 9 data centers across the world with a lot of metrics. One more thing I didn't mention, we also have Kubernetes clusters that also report the metrics and we aggregate them as well. So it creates, it's a lot of metrics. Good company. Yeah. Sorry? No. Specifically for us, the Prometheus is running on bare metal. It's a machine with 7 terabytes of memory, of disk space, and if I remember correctly, 180 gigs of RAM. It's 2 bare metal machines per DC for the aggregation Prometheus. We have a Prometheus in Cube that comes part of the Kubernetes deployment that we retrieve metrics from it, but we don't deploy our main one that way. Yeah. Mm-hmm. That's one option to do it. I know. Yeah, we heard it. The only issue for that is that we want to have alerts and to have them fresh. But you're correct. That's something that even one of the Tom from Grafana also told me to try to look at. It's an option. We need to consider it. Any additional questions? Okay. Thank you very much for your time.
Thank you, Michael. Okay, it's 6:15. We're going to have a 10-minute break to grab some food, grab a drink, and then we'll meet back here. Food's back in the kitchen. the next Cortex.
No one's allowed out.
Okay, we could start making our way back to the seats.
You're up.
Best. Okay.
Okay, we're going to get started with the next talk. Keep it going, or is it going to be here all day? Okay, so Dieter from Grafana Labs is going to be talking about Graphite and MetricTank.
Hello, everyone. So I'm Dieter. I actually had a pretty short flight. I just came from Cyprus, so for me it was only a 1-hour flight. Some of my colleagues had to come from much further. I am going to talk about Graphite and MetricTank, and you might be wondering, why did we already have a Thanos talk and a Cortex talk, and now also Graphite and MetricTank? How many different databases do we work on? Well, if my clicker works, I'll show you. Sorry?
Exit out of his presentation, then go back in again to the other one.
You get out of the
Yeah, something like that. This is obviously.
Okay, no problem.
There you go. Right now.
Thanks, Tom. All right. So yes, we are actually involved in a lot of projects. And the reason for that is Grafana Labs, we try to work with the open source community. And instead of trying to invent everything ourselves, we try to work with what's already out there. So that's why we're working with the Prometheus community and are heavily involved in that. And we're doing the same thing with the Graphite community as well, because there is a big community there of existing Graphite users. And that's basically our kind of philosophy for all the different projects. One more interesting exception perhaps is Loki, which is a logging system that we had to invent ourselves because there just wasn't anything like it. But for metric systems, we don't try to reinvent the wheel until we have to, basically. Okay, so what is graphite? Well, actually, Michael already told you everything about graphite, almost. And I was going to ask who knows about graphite, but since Michael told you about it, everyone already knows about graphite. So I'll change my question. Who of you knew about graphite before Michael presented it earlier today? Okay, good. That's a nice amount. I'm happy to see that because that means I can go a little bit quicker. Basically, it's a project that started quite a while ago. Fun fact, if you didn't know, Grafana was actually originally created specifically for graphite and then later expanded into other systems such as Prometheus, InfluxDB, Elasticsearch, and so on. So the data model, not going to spend too much time on it. You're probably quite familiar with the hierarchical data model, which has the benefit, if you have a very large data set, it kind of guides you into your specific navigation path, and it may help with speeding up your autocompletes if you compare it to tagging. Because when you're trying to complete autocomplete tags, it has many tags, all with a very large values space. But it has a lot of limitations. It's not very flexible. So as you can imagine, once you want to start adding things to it, you kind of break your dashboard queries. And it's not really easy to tell what is what. So some people don't know this yet, but actually quite a while, Grafana Labs added tags to Graphite. So it works actually quite similar to systems like Prometheus. This is probably not too surprising. It's more flexible, it's more clear because now you can see what is what. You can add and remove tags as you want without breaking dashboards. Yeah, nothing really special there. Just a comparison here between the hierarchical model and the tag model. I think this looks quite similar to Prometheus. Mainly, I just want to give the message, tags exist in Graphite, if you didn't know yet. And you're basically free to use whichever method you want. Although, to be honest, a lot of tools for Graphite will still emit hierarchical data and have not really switched over to tagged data yet. So sending data, you probably know this. It's quite easy. You just open a TCP connection and write string data into it. So selecting series gets a little bit more interesting. This is, of course, the standard pattern matching. But if you use tags, then it gets a little bit more interesting. So typically, you'll want to do a series by tag, and you'll typically want to start with the name tag. And then once you filter on the name of your metric, you'll start drilling down by other tags. This is very similar to how Prometheus does it, except you don't actually have to do it this way. Like you can start with a different tag if you want to. You don't have to start with the name. You can start with data center or whatever. So my favorite feature of Graphite, or the reason why it's still fairly popular, is it has a lot of processing functions. You can do sums across many series, get the minimums, the maximums, filter by average values, by percentiles. You can do summarizations, classify data into time buckets, linear regressions. You can shift data, so you can compare the current week with, for example, this week but a month ago, or the same month but a year ago. And it has also some more statistical functions as well. For example, exponential moving average, just to give a random one. Holt-Winters is kind of an interesting one. There's a couple functions around Holt-Winters. If you don't know what that is, it's basically a way for forecasting. So this is just an example of how that looks like. Let's say your input series is the red one. You can tweak a few parameters to control your forecast. There's a lot of science behind it that I only partially understand. But basically, you can set bounds, confidence bands, and if your data goes outside of that band, then it might be worth alerting on that. So that's just one of the many interesting functions that Graphite has. So the query syntax, you probably are familiar with this one, the traditional one. But if you didn't know, you can also do pipe syntax now, because there was a complaint also from my end that when you nest all these different functions, it actually gets quite complicated. And it's like, let's say you want to add a function here in the middle somewhere, it's kind of hard to edit. So we also added the pipe syntax a while ago. So now you can basically express the exact same thing. You're selecting your data and then you just pipe it into all your processing functions. But it just looks a little bit more elegant. Yes. So what everyone knows about Graphite is that you can easily transform series into other series and generate output series from input series. But there's this little trick that not a lot of people know, which is how do you reduce a series to a single point? And to do that, you can do consolidate by your series. So you can select like the minimum or the maximum or the average. And if you set the parameter max data points to 1, then you will basically just get one output point. So if you're ever wondering, okay, now I have these series and I just want to reduce my series to single points, this is the way to do it. It's not obvious. That's why I wanted to call it out explicitly. We also added function plugins a while ago. So basically now you can add any function you want to Graphite. So this is a very trivial example of a Python function. This one basically just uppercases your series names. So you get in your context and your list of series, and then basically what you do is you uppercase all the names. You have access to all of the data basically. So you could modify all your data points if you want to, but in this case, we're only just modifying the name to uppercase it. So you can basically add whatever function you want. And it's pure Python. So if you want to make API calls to an external service or whatever you want to do, everything is possible basically. But let's talk a little bit more about the ecosystem of Graphite. When I was looking at this URL, actually, this URL contains basically tools and software that's compatible with Graphite. I was kind of surprised just how many there are. 21 collection tools, 16 forwarders, 25 things for visualizing data. There's lots of stuff out there, and I want to talk a little bit about that as well. So the official Graphite projects, those are the Python projects. This is what Michael was talking about. But there's a lot of alternative backends, and this is actually where it gets quite interesting. If your problem is scalability and performance, and you want to use Graphite, then all these projects are interesting to have a look at. In particular, Booking.com wrote a Go-based stack that still works on Whisper, which is the files that Graphite works with. And they're able to get really impressive scale and performance out of just Whisper files by optimizing the hell out of everything, basically. That kind of turned into another project, Go Graphite, which offers replacement tooling, like basically everything of Graphite re-implemented in Go. There's some projects out there that try to bridge the gap between InfluxDB and Graphite. So if you want to use Graphite but backed by an InfluxDB database, you can do that. Even ClickHouse, which is kind of a popular analytics database, you can use ClickHouse as a backend for Graphite. Then there's this more experimental one, Kenshin. I just found this last week, so I actually haven't really played with it, but it's interesting. And then, of course, MetricTank fits in with all these other ones too. It's the Grafana Labs take on how do we make a scalable backend for Graphite. And of course, we're going to talk more about that in a second. Then there's some interesting Carbon Relay alternatives as well. Carbon C relay, nanotube, and GoRelca. These are all mostly focused on performance. They're interesting to have a look at. I actually also wrote another carbon relay alternative, which is called Carbon Relay NG. I think it also came up in Michael's talk earlier. It focuses a little bit more on functionality. It also performs better than the Python one. It can handle up to like 1 million or a couple million per second. But if you want extreme performance, then the other ones are actually more optimized, and you should have a look at those. Although we also plan to optimize Carbon Relay NG further to make it more performant. Okay, so my personal pros and cons about Graphite. It doesn't perform so well, especially if your queries use a lot of data. Everything is in Python, the processing is not very fast. You may get slow queries or timeouts even. It uses a lot of resources, especially because the file format Whisper doesn't use compression. It does not handle high churn series very well. So use cases like Kubernetes or containers where you have a lot of churn in your data because you're constantly creating new containers and new series, it doesn't handle that very well. It's a pretty quiet project. Most of the innovation is actually happening in basically all these projects and some of those. So that's kind of interesting. Yeah. And it doesn't scale very well. I think Michael also alluded to that earlier. It does scale, but it involves a lot of manual copying of files. But it does have some pros as well. And I think the main thing is really the rich library of all the processing functions that you can do, and you can make your own processing functions. It's quite a powerful query language. It has long-term storage and seamless rollups, but apparently Thanos and Cortex are also doing that nowadays, so maybe I should remove that from this list. Although maybe Tom can answer this, but you were talking earlier about downsampling, not so much creating aggregated like min, max, average and all that. I don't know, does Thanos and Cortex also do min, max, average, or is it mainly just sampling? By taking aggregates. Okay, so Thanos and Cortex now also.
Cortex kind of doesn't use.
Right, okay, all right. Okay, so then I should probably remove this item from the list because it's no longer unique to Graphite. Same with this one, really. Graphite is push-based, as you probably know, which makes some things a little bit easier. Like we offer a cloud platform, and just pushing from a customer to us gets a little bit easier. But I feel like this push-pull debate is like mostly about implementation details, and in my opinion, it's not really worth obsessing over. But another strong positive about the Graphite ecosystem is just how much there is available already in terms of producers of data and tools that you can use with it. All right, so let's talk about MetricTank. This is WorldPing. WorldPing is literally the first service that we ever created at Grafana Labs. And to power WorldPing, we needed a time series database. So we looked at a lot of things out there, and our criteria were it needs to support a large scale. So we needed something that could handle millions of points per second and hundreds of millions of active series. We needed something that did long-term storage and rollups, which apparently is the exact same thing as downsampling in the Prometheus world. It needed to be resource efficient because this was our problem with Graphite. And even alternatives such as KRasDB, we weren't getting the efficiency. Even when systems were based on Cassandra, which we were also looking at, they weren't using it very well. We needed it to be very cheap. We needed multi-tenancy, of course, because we have so many customers, and they should not be able to read one another's data or affect each other. When one person is doing heavy queries, that shouldn't affect somebody else. It needed to be open source. That also cut out some solutions that are like partially open source. It needed to be operational friendly, of course. We were also interested in more proven technology, and I'll get back to this in a bit. Like we actually ended up choosing Cassandra because of that. And of course, this was important to us. We wanted to be compatible with Graphite because a lot of our customers were already using Graphite and still are. And we wanted to make sure that we were compatible with that. So we started building MetricTank because, like I said, this is actually 5 years ago, actually, at this point already. So there are some technologies that exist right now that didn't exist back then, but there was nothing really that met all of our criteria. But we took a lot of shortcuts. So for example, for the actual storage piece, we use Cassandra, and now we actually also support Bigtable. For the compression of the data, we use a library called GoTSZ, which is based on the Facebook Gorilla paper, which is a very popular library. It's also used in projects like Prometheus even, or very similar as what is used in Prometheus. InfluxDB uses it as well. So we didn't want to reinvent the wheel, and we tried to keep it contained, the amount of work we had to do. We wanted it to be a scalable platform. We didn't fully achieve the automation of that. I would say that we do have a scalable platform, but if you want to scale out, it still involves some manual work. I mean, I find it manageable, but yeah. Performance is getting quite good, especially when compared to Graphite, because we have a lot of caches. We have chunk caches, we have caches on the index, and we re-implemented a lot of the Graphite functions into Go, and it's a lot more optimized, and we see orders of magnitude reductions in query latency. We don't have all of the Graphite functions re-implemented yet. So when there's a query that contains a function that we don't support, then we actually proxy to Graphite. And when that's not the case, then we handle everything internally. So over time, we gradually just build out the list of supported functions and handle more and more ourselves without having to proxy to Graphite. And that gives us much better performance. Costs. When we compare to KairosDB and everything that was out there back then, we were significantly cheaper. But actually, from listening to Tom and the trade-off between Bigtable and Cassandra, we should give that another look, and we should probably also start looking at object storage, just like Thanos. And maybe there's opportunities for collaboration there. I'm sure we will look into it. And of course, different customers have very different workloads. I've experienced that firsthand. So we have a lot of tunables in terms of retention. And for some people that do have index churn or series churn, there's a lot of tunables for the index where we can control how long each series should stay active in the index. Of course, you can configure how many replicas you want. Let's see. Okay. So when comparing MetricTank to Graphite, as I said, the native functions execute a lot faster, but we have not implemented all of them yet. We're actually only about halfway. Even though we get more than 90% of queries get handled by MetricTank itself. So the vast majority do, even though we only have about half of the functions implemented at this point, but we keep working at it. Another interesting thing is with Graphite, you can't really easily change the resolution of your data. If you have collectd or statsd or something sounding at 60 seconds and you want to change it to 10 seconds, it's not really seamless, but with MetricTank, it just handles that, and you can change your resolution and it will just merge it on the fly. So compared to Graphite, we do support series churn better, but I would say not to the extent that a Prometheus-based system does, because Prometheus and Cortex and Thanos, they all have a time-sliced index. We don't. So if your workload is very much a Kubernetes workload with containers constantly spinning up and down, this is maybe not the best choice for you. It's really a little bit more based on the longer term series. Another difference with Graphite is you can actually have multiple rollup functions. So with Graphite, you're limited to only the average or only the minimum or the maximum. But with MetricTank, you can configure however many you like, and you can query any of them. There's just one catch, that if the query goes through Graphite, that selection is not passed on yet, but we're working on that. If the query goes through MetricTank, then you can choose whichever rollup you want, which really helps with certain queries. Like if you have a summarize and you want the maximum values, then you need the maximum rollup. Meta tags, I'll talk about that in a minute. It's an append-only system, MetricTank. With Graphite, you can go back in time and overwrite old data. With MetricTank, you currently cannot do that, but we will work on that in the future. I need to go slightly faster. So this is the diagram. Basically, you'll typically write your data into your gateways, which basically just write your data into a Kafka cluster. Then your Kafka cluster is consumed by different MetricTank nodes. Whichever MetricTank has a primary role will save your data into Cassandra or in Bigtable for persistence. And your queries will be handled by any of your MetricTank pods or processes. And obviously, they will need to read from the database if necessary, but they also have caches. There's a little bit more nuance in there, but I'm going to have to skip over that. But there's a lot of flexibility in how you set up your cluster. For example, you can have one process handling both reads and writes. But if you want to play it really safe, you can have separate writers and separate readers. That way, if someone does an extreme query or something and it crashes some of your read nodes, then your write nodes are not affected. So that's a choice that you can make. We originally started that path, but I think it's been proven stable enough now that we're just going to merge those roles again into the same process and get rid of that redundancy. You can have a separate pool of query nodes, which also helps for high availability, basically, or with restarts, because if your pod doesn't contain any data, it's much quicker to restart, whereas read pods will have to read all the data from Kafka again, or at least the last 7 hours or so. Currently, the primary role it can be dynamically reassigned, but currently it's not automated yet. We've been thinking about automating it, but we just simply run it in Kubernetes, and we just say, okay, we want this many pods as primaries, and if it dies or an upgrade, the Kubernetes will just restart it anyway. So we haven't really had to make that process much better. So meta tags. This is actually really interesting because when people talk about time series databases, they always talk a lot about high cardinality and how can you blow up a database if you have very high cardinality. But meta tags is kind of the opposite. It's how do you handle very low cardinality? If you have the same tag, like let's say you have a data center tag and you have 9 data centers like Taboola, then you only have 9 possible values, but you have 100 million metrics, and each of them is just only going to have one of those 9 different values. So is every single metric going to have that value applied to it? That would be very expensive on your index, and that would consume a lot of RAM. So what meta tags is, it's basically a way to add rules where you say everything matching this application and these servers automatically also add this data center tag, this app version tag, or whatever. And you can add many more tags to your existing series through these rules in a very cost-effective way. And it's actually seamless. Whenever you do query, you can't tell the difference between a regular tag and a meta tag. It will just seem as if they're native tags, but they're much more efficiently stored in the index. So yeah, it's flexible associations. So you don't have to modify your series at all. You can always dynamically say, okay, now all these metrics, they're going to be this data center or they're going to be this application version. And then tomorrow you can change the application version tag without having to modify any of your data stream. So yeah, for autocomplete, for grouping, filtering, aggregating, they just look like real tags. It's interesting to compare this to Prometheus as well, because in Prometheus, you solve a very similar problem with a separate series, and then you have to do a join on them. You can bring in additional tags into your series by joining on certain series. But this, in my opinion, feels a lot more native because you can't tell the difference, and you don't have to do any joins or anything like that. This is one of my favorite features about MetricTank, speculative query execution. So imagine you have, let's say, 120 nodes in your cluster. Whenever a query comes in, you want to fan out to all of those 120 nodes because they all have a subset of the data. But what happens if one of them is very slow? Because maybe it's doing a garbage collection cycle or something like that. So maybe 115 of your nodes all respond very quickly, but just 5 of them or just a couple of them are a little bit slower, and you don't want to hold back your entire response. So Oh yeah, and then the other thing is we actually found a bug in the Go runtime. You're probably aware Go has a garbage collection, and it even exposes the latency, like how long it takes to do the garbage collection. But we found this bug where if Go tells you garbage collection took, let's say, 10 milliseconds, we actually see pauses of maybe a second or more. It's a very interesting conversation. If you're interested in the Go runtime, you should read it. So this basically makes this issue a lot worse. So what speculative execution does is you can configure a threshold. Like let's say you fan out your query across your entire cluster, you get 115 back. At that point, you can decide, okay, instead of waiting for these few replicas, I'm actually gonna issue the same query to the replicas of that particular peer that we're waiting on. So if it's shard 119, we have a replica of that, which is going to send it to the other one. Hopefully, it will respond much quicker. So we have this example. I'm going to show you some stats from a real cluster that has 120 shard groups. So that's basically shards of data with 2 times replication. So in total, it's 240 peers. On this particular cluster, we were seeing about 67 requests per second, but they're all fan out across the entire cluster. So times 120, that's about 8,000 requests to all the peers in the cluster per second. And the speculation threshold that we set was 94%. So basically, we wait for 112.8. So really, it becomes 113 nodes. And after we've got a response from 113, then we're going to send those last few requests to the replicas. I'm going to try to go a little bit quick over this, but basically, this is the percentage of queries that became faster. So we saw that 100% of requests became faster. Let's see. So the additional amount of requests is here. So it was about 4% of additional requests that we were doing on this cluster. And basically it showed that 100% of the queries became faster. So it was a no-brainer to just enable this and issue a couple more requests and everything speeds up. And this shows the latency on the bottom. Let's ignore this period in the middle here because this was a rollout that had some issues with the rollout. But basically, here, this was a QA cluster. Here we're starting to introduce the speculative execution. So I don't know how clear this is, but you can see here that your median and your P90 and your maximum queries, they take easily several seconds. But then once you roll out the speculative execution, this is much flatter. And most of the queries were just a couple hundred milliseconds. Another feature that we added is response metadata. Basically, lots of stats about how many series do we return, how many points did we have to fetch from the storage, how many points were returned, cache hits, all those kinds of stats. Now we can get those in every single response. So the idea is that in Grafana, we're going to start visualizing this. We're going to make an integration with Grafana. And then also, for every single series that we return, we also return which schema does it come from? Which of these archive did we read? Did we read a roll-up data? Did we read the raw data? Did we have to apply any runtime consolidation? Because the problem that we were seeing is a lot of people were looking at their charts and they were like, something looks wrong about this chart, but I don't know why. And it turns out maybe it was runtime consolidated or it was read from a roll-up archive. So now we return all that data, and I'm also working with the Grafana team to visualize this in Grafana. And this is just a very early mock-up. But basically, when you get your response in Grafana and your chart, you want to understand exactly where does all this data come from. It's going to be able to say, for example, one of your series came from this configuration from your schemas, and 158 series came from this configuration in your schema, and we read this time range from this particular rollup, and then we did additional processing, such as runtime consolidation. And it will explain why and what function it applied. And basically, we're going to make something visual like this in Grafana. Future work. So we want to try to help the Graphite project with governance. So this is something that we're working on. And we're actually hiring for this position. We're looking for someone who can help us with bringing all the projects together. Because like I said, there's so many interesting work in the Graphite ecosystem, the Go stack, the Carbon API stack, and so on. We want to bring all this back together into the original upstream project so that it's much clearer for people what the project actually is, and bring some of these innovations like the faster relays and the faster carbon processes back into the official project. For MetricTank, of course, we're going to keep building more and more native functions. Chunk streaming, that's basically an optimization in the cluster. I'm not going to go too deep into that, but it's going to help us reduce response times. Meta-analytics, so this will be an enterprise feature for MetricTank. This is going to be able to tell you where in my metrics hierarchy do I have a lot of data? And if I have a sudden increase in my active series, where is this coming from? Who generated all this additional metrics? Those kind of questions will be able to be answered with meta-analytics. And you will also be able to overwrite series, which currently you can't do. You can't go back in time after you've already written data. You can't overwrite that data, but we're going to work on that to support that. And like I said earlier, we're going to work on the performance of Carbon Relay NG as well. So if you're interested in MetricTank, you can join our Slack channel. And also, like I said, we're hiring both Python developers for MetricTank as well as Go developers for, sorry, did I say Python developers for MetricTank? I meant Graphite, of course. And Go developers for MetricTank and for our other cloud projects. And I think that's it. So I'm sure we have a couple minutes for questions. Yeah. Yes. Do we plan to support the Graphite query language? Mm-hmm. Okay, so you're looking to store your data into a Prometheus-based system, such as Cortex or Thanos or Prometheus itself, and be able to query it using the Graphite query language. Do we plan to? Well, we don't have any immediate plans for that, but you know, we are Grafana Labs. We try to work with the Graphite community and the Prometheus community and try to bring everything together. So it's something we should do and we should be thinking about, and it's on a list somewhere. It just hasn't been high priority for us. I would like to talk to you more, maybe offline, to see how we can help. It's definitely something we would like to do. Any other questions?
Yeah.
I'm sorry? You should be able to pass the tags through the relay, I believe. I actually personally haven't tried it in a while. StatsD doesn't support tags yet. This is something that if we had one more engineer, we could probably tackle that problem as well, but yeah. Currently, StatsD does not have tag support as far as I know. Tom?
What scale do you want? I actually legitimately don't know.
On our production cluster?
Yeah,
I'm not sure if I can share the real number. All right. It's about 200 million active series. Yeah. And the ingestion rate is a couple million per second. Yeah.
It's about twice what we use.
Yeah. Any other questions? All right. Well, I can do my Grafana talk, Grafana 7 right now, I guess, or a little break, or?
Roadmap talk. And then we've got the room until 8 o'clock. So we can stick around after the talk and have a couple more drinks and chat, but we have to be out at 8. Okay.
Yes, I don't know how to use the mouse on your computer, apparently. Oh, there it is. Where's the mouse? All All right. Grafana 7. So, if it wasn't clear to you yet, I'm not a Grafana developer. I work on Graphite and MetricTank. So I'm going to try my very best to impersonate a Grafana developer and tell you everything about Grafana 7, even though they just tell me what I have to tell you. So, oh yeah, I should probably mention Grafana 7. We plan to release it in May for GrafanaCon. So, the main highlights: a better out-of-the-box experience, make it more accessible to general users, not just power users. Speaks for itself, I think. It's currently a little bit too hard to use. Actually, let me check the time. Okay, 19:05, got it. So that's a very user impacting feature. We're going to try to make it a lot more user-friendly, but also under the hood, we're making a lot of changes and really working on the underlying platform as well. And I'm going to talk about that in a second. We're also going to be working on new visualizations, as always, I guess. Improved panel editing and an integration with tracing. So I'm going to show all of these things right now. Let's start with the platform. So one key concept in this platform, and this might be a little bit more interesting to developers who like to work on the Grafana code base, but basically, we have this concept now of a data frame, because in the past, the problem that we were seeing is that we had some data structure for time series, and then we had another one for tables, but it was very, not really well, it's not really ready for the future. So now we came up with this columnar data model that we call a data frame, which is basically a data format where everything is stored column by column, and every single column will have metadata, such as what is the unit, is there any thresholds, how do I want to visualize this column. This will also make it easier to filter on certain columns. So yes, this is a pretty cool feature. Provides rich metadata and field configuration, because what it enables is data sources such as Prometheus and such as MetricTank, such as Cortex. We will be able to say this particular series has this unit, or this series has a certain threshold on it. Like, data sources will be able to provide it to Grafana, and then Grafana can just interpret that and include it in its visualization. Or you can even set global rules, like this series, I always want it to be visualized in red or in green, for example. So a lot more metadata and configuration on your data, and shared transformations as well, because this is something that we saw in our different plugins. Like if you look at the table plugin or the single stat or the graph panel, many of them had some kind of ways of transforming data, but it was always specific to one panel. So now we're generalizing that and just making everything more powerful. So is anyone like really super excited about this, or you probably maybe, who of this is just more of a user of Grafana and not so much a developer working on Grafana technology? Right. Okay, that's what I thought. So cool stuff, thanks Grafana, but let's move on. Plugins. This is a little bit of the same kind of stuff. I think we're migrating a lot to React. There's a lot of advantages to React.js apparently over AngularJS. I think performance is one of them. New APIs for backend plugins. But this is something that I'm pretty excited about, because I've been talking to Ryan, who's kind of leading this effort, is we're going to do a lot of effort for testing our plugins, because so many people are writing plugins and sometimes they break when there's a Grafana upgrade. So now we're building out this big CI system that makes sure that every single plugin will always work against a certain Grafana version. So we're working on a testing platform that's basically going to make our plugins much more reliable. Again, if you're a plugin developer, then this probably means more to you than it does to me. But basically, these things are like reusable packages, like React libraries or something that you can use for data processing and basically UI components in Grafana. Like if you want to make your own widgets or panels in Grafana, then you're able, or you will be able to reuse these existing libraries. All right, let's talk about something a little bit more visual. Yes, there will be new form styles and components for a modern look and feel. No, Okay. There will be some screenshots coming. Yeah, I know it looks a little plain, but trust me, the good stuff is coming. So there will be new experience. I'm going to show it in a second. Ability to discard changes. Let's see. Unified options. I'm going to show that in a second as well. And a unified override UI to specify visualization settings. That was basically what I was talking about earlier, that you have more central places to say how you should set thresholds on certain data or visualize certain data. But yes, it's going to get more visible in a second. See, there it is. Okay, so what are we looking at? Panel options. Yes, so Torkel told me this is very much a prototype. So the exact design is going to change, but the key elements are basically that you can set certain things, like for example, thresholds. You can say, you know, if it's over than 50, it should be blue, but then when you change the visualization type to something else, those settings will be kept. And so that's kind of the idea behind a lot of this, is that a lot of these settings and aggregations and overrides, that they are more effective so that you can easily change to different visualizations without losing all your settings, basically. So this was not a video, right? I know that there's a video in here somewhere, but I don't think this is it. Anyway, I see the Prometheus documentation here, so. Yes, new table panel. There's a couple of issues with the table panel that people have been talking to me about. This is a video. Okay, great. I just don't know. Okay, actually, I do know, probably. It's on the screen, great. Yeah. Here we go. So the new table panel, as you can see, one of the new features is that you can now add visualizations into your rows of your data. So it could be a gauge or a histogram or a chart or anything like that. And there's a lot of issues fixed with this. I think the columns are also a lot more dynamic. Like you can play much better with the widths and stuff like that. From what I've been told, it should work a lot better. Panel inspector. So this really becomes useful when you want to see where does this data come from. And this ties in with the kind of stuff I was talking earlier about a MetricTank, where you're looking at your chart and you want to understand better where's this data coming from. So you'll be able to analyze the query request and the response, troubleshoot your errors, download your data as CSV, which I think is already possible, but this is probably a new and better way to do it. I don't know. And it's going to be available for all panel plugins. That sounds like a good thing. Yeah, so here, this is basically just a screenshot of that in action. So this will be the inspector. Here you'll be able to look at all your rows of data and get statistics about them and things like that. And this is also where you would see basically the mockup that I was talking about earlier. That would also fit in there. Observability. Yes. So how many of you are familiar with the Prometheus and Loki workflow? Tom, you're familiar with that? Okay, great. All right, well, I'm not going to do the demo, but basically the idea that we're trying to do in Grafana is we're trying to integrate all these different systems with each other. And Prometheus and Loki are the first to do that, so Loki is a logging system, by the way. Maybe I should mention that. But the key idea is, let's say you're looking at a metric, maybe it's showing errors on an application server, and you have your query showing your errors. To basically convert that query to a Loki query so you can see your logs for that specific service, for that specific time frame, so you can see the logs straight away corresponding to those errors. So that's a feature that works right now between Prometheus and Loki, and that we're trying to extend to other metric systems and also to other logging systems. But now we're trying to extend that to tracing as well. So if you use a tracing system such as Jaeger, then you'll be able to do things like this, where you have a trace ID in your log file, and maybe you know that this is a problematic request. So you click on the trace ID, and you'll be able to see the trace. So yeah, Jaeger support is coming in Grafana, and we're going to try to integrate it as much as possible with the other stuff as we can. Aha. Yes, this is the demo. Good. Yeah.
Yeah.
So this is basically the workflow that I was just explaining. You have some errors in your charts. So you go to explore mode where you see that same query, the same data, but now you can tweak your query a little bit just to narrow down to the errors that you want, or change it to a Loki query, which keeps the same selectors. So the same job, the same application, the same service, whatever, it will keep those same labels. So you immediately get those logs for those errors metrics. And then if you have a trace ID in your logs, then you'll be able to go straight to the tracing view. So this is a prototype right now, but we're working on doing this for real. Documentation, yes. Improvements to the Grafana documentation. Improvements are coming. Yeah. And a learning platform focused on guides and tutorials. This is actually pretty cool. I was looking at our upcoming tutorials, and I was so close to writing a backend plugin because there was this really cool tutorial for how to make a Grafana backend plugin. So soon we'll have this platform with all kinds of guides and tutorials, which is going to be pretty cool, I think. Okay, enterprise. So I think this came up earlier. Somebody asked, how do you make money? Or I think Edward was explaining it earlier. Well, Grafana Enterprise is one of the ways in which we make money. Same thing, by the way, there's MetricTank Enterprise, there's Cortex Enterprise, and so on. But Grafana Enterprise, meta-analytics, this may sound similar to what I was saying earlier with MetricTank, where you can say, in MetricTank's case, you'll be able to say, where are all my metrics coming from? Who's generating these metrics? It's very similar with meta-analytics for Grafana, which will be able to tell you which of my dashboards generate the most queries, which of my dashboards have the most query errors. Basically, you have a lot more insights about what's going on with your Grafana instance, a lot of statistics about who's doing what is creating problems, who's making slow queries, all kind of things like that. So that's an upcoming enterprise feature. And this is how that could look like. Well, it looks quite blurry. I can't even read it. But this says top dashboards, I think top dashboards with errors, top users. I don't know, but you get the idea. You basically get a lot of top lists and get a better understanding of your Grafana. This must be the last slide because my clicker is no longer working. I'm pretty sure it is the last slide. So I'm happy to answer all of your Grafana questions because I know a lot about Grafana, I promise. Yes? Yes, they're coming. They're just not coming quite yet. So the plan is basically after Grafana 7, which we plan to release in May. After that, we want to start working on alerting again. We have some ideas for improvements, but yeah, later this year, basically. Yes.
Right, does Cortex support MetricTanks?
Does Cortex support MetricTanks? No, we have real. Sorry, I'm taking.
Sorry, Dieter. The question was, does Cortex support meta tags? No. Oh, does Cortex support metadata? Yeah, so Josh is actually working on that right now. And it should be in, if I say a few weeks, it will be in a month.
Any other questions before we wrap up? Yes.
It's like similar to what you saw in Loki. With other widgets.
Yeah, you should check out Grafana variables. That's basically exactly what you're describing. You can specify.
The question is,
a widget is just a UI feature, right? Like variables do exist in the UI. But yeah, you can specify queries that return, let's say, a list of instances, and then you can use them templated within any of your queries. And that will allow you to like select the instance you want to look on, have the whole dashboard update, and only focus on that one instance. Let me show you a demo afterwards. Yeah.
All right. It doesn't look like there's any more questions, so let's end here.
Yeah, I just wanted, clap, applause. So we probably don't stress this enough, but we really, really want to hear your feedback and if you have any particular requests for Grafana. We care about the community and we care about what you guys want to see in Grafana. So this is our ideas that we actually centralized so far, and we want to focus on Grafana 7. But if you have any other ideas of things that you'd like to see in Grafana, we'd really want to care and hear about it. Whether it's now, if you have something to share, or later offline, you just reach out to us. And thank you very much to Taboola to actually hosting us today. We have the room for 40 more minutes, so yeah.